Okay, we're going to try and make this the fastest recording in all of history for any of the videos I've made like this. This is the first section in our study on the galaxy from section 25.1. We start off by talking about William and Caroline Herschel. They were brother and sister, and back in 1785, they used the largest reflecting telescope they had at the time to count the numbers of stars in every possible direction and kind of keep track of that. And so since they discovered about the same amount of stars in any given direction, they inferred that the sun was at the center of stars all around them set out in a rough disk. Now, because of limitations, mostly because they were just using a visible light telescope and it wasn't that strong, as you see here in the picture, they got the rough shape of things, roughly disc-shaped, correct, but they got the size incorrect. As you see in this larger picture down here, the sun is not in the center of things, and what they were able to see corresponds to the dark area here, where the other white points correspond to other major stars in the galaxy. But it was at least a starting place. We now know with modern telescopes that are able to take and measure and observe both infrared and ultraviolet and radio waves from very far distant parts of the galaxy that would be invisible to normal telescopes. We have a picture based on those measurements and observations of roughly what the galaxy looks like. When I say roughly, it's pretty darn precise considering that we've never been outside the galaxy in order to see it. So astronomers take all of this data and all these measurements and use it to sort of construct this picture that we have of our galaxy as roughly a big rotating disk of stars that's about 100,000 light years across. At its thickest point in this area, it's about 2,000 light years thick, if you look at it from the edge on. Most of it is in a thinner disk that's about 400 light years thick. There's more to it than just that. There are also several globular clusters of stars that are outside of that main disk. Our own sun is about 26,000 light years from the center of the galaxy. And the center of the galaxy, there's actually a bar structure surrounded by several very concentrated areas where there are a lot of hot young stars. We refer to those as spiral arms. As I mentioned a minute ago, most of the matter in the galaxy is concentrated into a central bar and spiral arms. There is quite a bit less of it that's in a thicker disk. If you look in this photo here, which is a composite of several photos taken from our position in the galaxy looking inward, the darker areas there are denser, those denser parts of the spiral arms. All of this fuzz on the outside here, this is from a much fatter disk. But even though it's fatter, it's much less dense. The stars are much more spread out. In the middle, there is a central bulge, which is where the fattest part of, and you can only see a portion of it right here, it actually is sort of peanut shaped. They used to think it was roughly a sphere. They now know it sort of bulges out either side. If you zoom out from what we were looking at, you've got the galactic center, which is the bulge. You've got the thin disk in the center, the thicker disk around the outside, but the material that makes up our galaxy actually extends out to a radius of about 150,000 light years to some very, very old stars. We refer to this area as the galactic halo. Beyond that, if you go out another 50,000 light years or so, then there is another halo that we can't see. And we know it's there because of the way that it affects gravity. There's quite a bit of mass out there, but since we can't directly detect it, we have just nicknamed it dark matter. And as of now, nobody really knows what it is or, in fact, how much of it there is. And on the final slide here, I told you this would be fast. This is just a table showing some of the different properties of different parts of the galaxy. You've got the thin disk, the thicker disk, and then the first stellar halo. And so you can see about how much of it by mass compared to the sun. Luminosity, again, compared to the sun. Typical age of stars, you see the youngest stars are located in the thin central disk on those spiral arms. The thick disk, they're a little bit older, and then they're even older way out there in the stellar halo. That concludes this particular slideshow. So I'm going to pass it over to the next person in line.